Welcome back. We just finished preparing our data to get z-scores. So in this video, I will show you how to do that. Now remember, in the last video, we created transforms to normalize the data. Just remember that if your data is already assumed to be normal, you don't have to do any transforms to it. You can go directly to getting z-scores, which is what this video is going to show you how to do. Now remember, there are two files below. Go ahead and open them up. You have the spreadsheet as well as the directions. We'll be referring to both as I share my screen, and I'll show you how to get these z-scores. Now, essentially, we're going to start where we left off with the last video. So here's our spreadsheet. We have our original data, the satisfaction data. We have the alcohol data. Those are all originals. And then remember, because satisfaction was skewed, it was a negative skew, and alcohol was a positive skew, we transformed those variables to get our transformed satisfaction. We squared the values. And then for alcohol, we took the square root of those values to normalize the data. So when it comes to getting z-scores, because we want to assume a normal distribution, you're always going to be using the transformed data. So we're going to be looking at the output here for both the transformed satisfaction as well as the transformed alcohol. Now let's take a look at the directions. Let's make sure we know what we're doing before we do anything in the Excel spreadsheet. So we already did steps 1 up here. We're going to move down to step 2 where we have z-scores. So remember, in order to get z-scores, you need to have a mean and a standard deviation of your variable. In this case, we want to make sure we use the transformed mean and standard deviation. Remember, it's the transformed variable that we are assuming to be normal. So the steps for creating our z-score variable, we're going to create a new column for data. You can name it whatever you like. I like to keep it simple. So if I'm getting z-scores, I'm going to do z, then underscore, and I'll put the original variable name. We're then going to write our formula out right underneath that new label for the z-scores. That formula is equals. We're going to take the original values or the cell number, the observation. We'll subtract the mean, and we'll get that mean from the output. We'll close parentheses, because we want that subtraction to happen first before we do the division. So after that, we're going to divide by the standard deviation. In this case, again, for the transform data, because that's the one that we assume to be a normal distribution. Once we have that, we're going to drag that formula down like we've done before, and that's going to give us all of our z-scores. We can then double check just to make sure that our z-scores look correct. Our check for that is if we get our descriptives on z-scores, it should center at 0, so the mean should be 0, and the standard deviation should be close to 1. Now, because we are going to be typing in the data to 2 decimal places, there will be a little bit of rounding error, but it still should be close to 0 for the mean and close to 1 for that standard deviation. And then if you remember from the narrated PowerPoints, we can also categorize each one of our participants as being average, above average, below average, etc. And so we'll create a column and we'll do that as well. Let's go to our spreadsheet. The first thing I noticed right away is that we don't have room here to create our new variables, so we need to create some space. So it's a good idea that you know how to do this, but if you want to add columns to give yourself some space between your output and your data, you can do that. All you have to do is right-click on one of the letters at the top of the column, and if you scroll down, you'll see Insert. And so if you left-click on Insert, it's going to add a column. Now here, we probably want to add a couple columns. I want 2 columns for my z-scores. I want 2 columns for my categorization. So I want 5 columns, blank columns total. And that's going to give me some space here. If I do any kind of sorting, it's not going to mess up my tables for my output. Okay, so let's get some z-scores. So remember, we're going to put a new label here. I'm going to go z underscore. And for this first one, I'm going to put in status for satisfaction. To get that z-score, I need the mean and standard deviation, again, for my transformed satisfaction variable. So I'm going to scroll down to my output down here. It looks like the mean I'm going to use is 28.8 if I'm rounding to 2 places. I'm just going to highlight that. And the standard deviation is going to be 13.16. Now again, we're going to assume that we have sample data for this first example of getting z-scores. When it comes to the alcohol variable, we'll assume that's population data, and I'll show you how that is different when getting z-scores. And it's not much different but I still want to show you how to do it in case you come across it on an exam or on one of the assignments. Okay, so we're going to put that formula in there. So remember, if you're looking at your directions, that formula is going to be in parentheses the cell number of our variable minus the average or the mean from our output. We're going to forward slash and then put in our standard deviation. Now you'd be tempted here to just click on them in your output. Don't do that. Actually type them into 2 decimal places. You don't want that formula carried down through your output. You'll get a bunch of error messages. So make sure you type in that mean and that standard deviation. Don't just click on the cells that contain the values. Now back in our Excel spreadsheet, we're going to put that formula in there. It's going to be equals. I'm going to do an open parentheses. Now I want to get the transform satisfaction score. So I'm going to go to the column that says T underscore satisfaction. I'm going to click on that very first value that's underneath that header. In this case, it's a 4. Now I want to subtract the mean from that value, and I want the mean from the transformed output. That's going to be this 28.80. If we're rounded 2 places, it's going to be 80. So 28.8 or 0.80. We'll close parentheses. We'll put in our forward slash, and now we want to put in that standard deviation. And again, like I mentioned before, make sure that you're typing it in. Don't just click on the cell. Because if you do and you drag down that formula, the next one won't be divided by 13.16. It'll be divided by the variance of 173.09, and then the one after that will be divided by negative 0.69, which is not going to give you accurate z-scores at all. So make sure you type those in. We're going to divide by 13.16. Then I'm going to hit enter, and there's my very first z-score. It looks like for participant number 30, the satisfaction score of 2 on the original data, that they're going to have a z-score of negative 1.88. Now let's go ahead and drag this formula down. So again, grab that lower right-hand corner, left click and hold, and we're just going to drag that formula down. I will stop where the data stops for my satisfaction variable. That's going to be all the way down here where we see that 16. So as you can tell, that's fairly painless. We have all the values that we need. Now that we've obtained the z-scores for each of our participants, we can now categorize them to their location underneath that normal distribution. So I'm just going to put in another label here in the next column, which is going to be category. Now, if you remember from the narrated PowerPoint, when we have a normal distribution, we can divide this distribution up by regions based on the standard deviation, in other words, the z-score. So the center of our distribution is the mean. We can then divide it by standard deviations, which is essentially z-scores. So the center is a z-score of 0. One standard deviation above the mean is a z of 1, 2, 3. And the other direction is -1, -2, -3. Now remember, depending on where a person falls on this population distribution, if it's between -1 and 1, we're going to say that is average. If it's between 1 and 2, it's above average. And if it's greater than 2, we're going to say it's an extreme score. And because the distribution is symmetrical, it's going to apply in the negative direction as well. So this would be below average. And less than -2 would be an extreme score below average. So that means if someone fell between -1 and -2, so they had a z-score, let's say -1.25, we would categorize them as being below average relative to the population for that particular variable. So that means that we can categorize each one of our participants based on their z-score. Now you could go through and type in each one, but that would take a long time. It's usually a lot easier if you sort your column first for your z-scores. I'm going to go smallest to largest. So that way when I start to categorize each participant, I can drag down that label. So the very first one is a -1.88. We would say that is below average. It falls between -1 and -2. So anything that's between -1 and -2 could be below average, so I can drag down that label. We just drag it down just like we did with the formulas. We'll hover over that bottom corner and left click and hold and just drag it down, so just like before. Anything between -1 and 1 is average. So again, left click hold and I'll drag it down. And anything between 1 and 2 is going to be above average. And it doesn't look like we have any extreme scores here. But now I can say participant number 8 looks like their score of 6 appears to be average in relation to the overall population. Okay, so that's how you get z-scores. That's how you categorize. So let's do one more really quick. Let's get our z-scores for the transformed alcohol. But this time, let's assume we have population data instead of sample data. So it's going to make one small change in how we get these z-scores. Now remember, with the alcohol variable, we do have a couple missing cells. So let's go ahead and sort this column. Let's push those empty cells down to the bottom so we don't accidentally create values that don't exist in our data set. I'm just going to highlight that E column. I'm going to go smallest to largest. Don't forget to expand your selection. And now we should have those 2 blank cells at the bottom, which we do. And then let's go ahead and put in our label for the z-scores for alcohol. So z_alcohol. And below, we're going to put our formula. But before we do that, we have to make an adjustment to that standard deviation. So remember, that standard deviation is assumed to be for the sample. In this case, if we are saying we have population data, we need to change the standard deviation to reflect that. So to do that, I'm just going to go next to my standard deviation value, and the cell right next to it, I'm going to hit equals. I'll put in our command. So stdev, remember I showed you this in a previous Excel lecture. Don't forget that P for population, and then I'm going to do open parentheses, and I'm going to go back to my transform data. Remember, use your transform data here. It's the one that we're assuming to be normal. And I'm going to highlight all those values and select them. Close parentheses and hit enter. And you'll notice that that population standard deviation is going to be just slightly smaller than the sample standard deviation. Remember, the reason why we do that is to adjust for the fact that we're not measuring the entire population when we have sample data. So we have to increase that value slightly. So we have our population standard deviation now. Our mean doesn't change, it's still 3.39 in this case. Let's go ahead and get our z-scores for the alcohol variable. Put in our formula, equals, open parentheses. I'm going to click on that very first value, and the data set, in this case, it's a 0. I'm going to subtract the mean, again, my transformed mean for alcohol, 3.39. Close parentheses, /, so I can divide. I'm going to put in that population standard deviation, not the sample standard deviation. So I'm going to put in 2.72. And I'm going to hit enter. There's my very first z-score. It's a -1.25 if I'm rounding to 2 places. Okay, so let's drag that down. Left click on that square in the lower right hand corner. Hold it. We're going to drag all the way down to where our data stops. So again, stop where the data stops. We want to stop where our transform data stops here with the 10. You'll be tempted to keep going. Stop, because you don't want to add those zeros into your data set. It'll mess up your z-score calculations when you check your work. All right, so we have our z-scores for each one of our participants. So again, if I was looking and I wanted to know what the z-score was for participant number 14, it looks like that z-score for alcohol use would be -1.25. It looks like that is below average in comparison to the overall population. Let's go ahead and let's add our categories. So anything between -1 and -2 is below average. Anything between -1 and 1 is average. And anything between 1 and 2 is above average in relation to the population. And then anything above 2 would be an extreme score. So what we're saying here is that participant number 4 looks like their spending on alcohol is extremely above average in comparison to the overall population. And same thing with participants 61 and 66. And remember, their original data was spending about $80 to $100 a week on alcohol. And we say that would be extreme in comparison to everyone else in the population. So there's really only one last thing to do here. We have all our z-scores. We should definitely check our work. That's that very last part in your directions here. So we can double check our mean and standard deviation. If we've done our z-scores correctly, our mean should be close to 0. The standard deviation should be close to 1. It won't be exact, but it should be very, very close. So let's do that really quick, and then we'll call it a day when it comes to z-scores here. So what we want to do is we want to get our descriptives for our z-score for satisfaction and our z-score for alcohol. We want to check that mean and standard deviation. So at this point, you've done descriptive statistics many, many times. We'll do it 2 more times here. I'm just going to put my z-scores right below my original data and my transform data output. And you'll notice here for z-scores for satisfaction, that mean is really close to 0. That standard deviation is really close to 1. It looks like, in this case, our z-score calculations seem to be okay. Now let's do it for our last one. So remember, we used our population estimate for alcohol. That shouldn't matter too much. We still should get close to 1 for the standard deviation and 0 for the mean. Again, I'll place my data right below the output for the original alcohol variable and the transformed alcohol variable. And again, when I look at that mean, I am getting something close to 0 here, and a standard deviation that is close to 1. Now, because I'm using a population estimate here, a lot of times you'll see that these values may fluctuate a little bit more and be a little bit further away from 0 and 1, but as you can tell here, it's not that much different. So it's still a good check, just to make sure you didn't make an obvious careless error when doing your z-score calculations. All right, that's it for this video. I hope you have a good rest of your day.